All right, dudes. I'm going to make a little video here. A couple things I want to talk about. Number one, I feel like some people are really going to struggle with this concept of making the board. So here's my solution to you, and it's not kind of like breaking it down piece by piece, but let's talk about some of the things that are happening in MakeBoard, which takes n an integer value. N is the number of rows, right? And according to the problem set, that number is going to be between 3 and 9. We want a number between 3 and 9. So, as always, like pick a number like 3. Just say, okay, well, if n is 3, what are the values I'm going to be working with? Like, how do I want things to work out, right? And one of the things you're going to want to think about is if n is 3, that the value in that top left corner is going to be 8, right? Starting 8, 7, 6, 5, 4, 3, 2, 1, right? So how do I derive, 8 from 3? Well, there's probably many ways to do it. So then you got to think, well, what if it's 4? What should that number be? 15, right? Well, if it's 5, it should be 24. Oh, I see. It's actually n squared minus 1, or n times n minus 1. So when I create val here, that's just like sort of that starting value, right? Now, first thing I do is I say for I in range n, board.append rows. Or not rows, but lists. Well, they're essentially rows. Yeah, that's what these lists are. They're lists of rows, essentially. So remember, the board itself is a list, right? But it also contains lists in it, right? And so that's the first thing. That's kind of like a big idea. And I think I showed you, like, that's the way it's supposed to look at the end, like a list of lists. Like, here's a couple different outcomes over there. But, okay, so then I say for I in range n. Okay, so now that I've created this list, I want board index I, which is the first, because I right now is 0. So I say board index 0 to append. So it's that first list I just put inside the overall list, append the value, right? And so think about what's going to happen the first time that happens. Well, 8's going to be put in there. If n is 3, 8's going to be put in there. And then I'm saying val minus equals 1, right? Now the way that inner loop works is, or the way the looping structure works, is that inner loop's going to fully execute. So I'm not going to go back to the for I in range n loop. I'm going to stay inside the for j in range n loop until I'm done executing it. So I still have two more times to go here, and I is still 0. So when I say board index I, it's still board index 0. It's still the first list in the structure, which, by the way, right now only has one list. So that's, that's good too. And then I append value. Well, value just decreased by 1, so val is now 7. So I just put a 7 in the second spot. Remember, append is like sort of adding things onto the list. Now val becomes 6, and you go back up there again. You do it again. Now, once you've done it 3 times, right, you're going to be done with the inner loop. You're going to go back to the for I in range n loop. You're going to append another new list, empty list. I is now going to be 1, so that when we go inside the next inner loop for j in range n, and I say board index I, I'm saying the second list in the larger list, which is board. It might be hard to kind of conceptually see this. This is where, like, paper pen would be nice, or if I could kind of write this on the board, it might be easier for you to understand. But anyways, so that's what happens, and it's all good. It's all good. So, and we get this kind of 8, 7, 6, 5, 4, 3, 2, 1, 0 kind of thing when we look at board. So then an issue becomes, well, what about switching those last two spots? And here is a little cheat. This is a cheat Aruni in Python. So it's like a Python, the swap, which I really actually probably shouldn't show you, but the swapping algorithm is a classic algorithm. It's one that you're actually expected to know for the AP exam, so we should actually talk about this idea. So first of all, if n mod 2 equals 0, that means like the row is an even number, right? Well, I have to consider, the 2 and the 1 and kind of where they are in the list, and maybe it's actually easier to see in this case here. But, if I'm looking at 2 and 1 right here, or if I'm looking at 2 and 1 here, obviously there's a different way to specifically access them. Like this is board index 2, 0. This is board index 3, well, right here would be the spot, but board index 3, 1, right? So it's a little harder to define where they are in the list. But I would say this. Well, actually, interesting. I didn't even think about this, but so I thought of it in terms of n. So in terms of n, well, that last row. I mean, so if n is 3, this last list is always going to be in index 2. Because 0, 1, 2, right? If n is 4, this last index is always going to be in the third board index 3, because this is 0, 1, 2, 3. So I was kind of thought like, oh, well, the last list is always going to be board index n minus 1, whatever n is minus 1, right? And then same thing, the two values I'm talking about, so the last value is always going to be 0, right? But the two values I'm talking about for 1 and 2 are going to be, if this is n minus 1, well, they're going to be in the n minus 2 and the n minus 3 spots. So again, if this is n minus 1, this is going to be the n minus 2, n minus 3 spots. Well, we did talk about this thing about indexing, reverse indexing. So this is also perfectly valid, right, in Python, right? So it's just saying the same thing, saying the last list and then saying 2 from the end and 3 from the end, basically. So that would be a way to do it. Okay, so that's all the same, but still doesn't kind of take out this fact that still doesn't kind of take out the fact that I am sort of using this little cheat to swap. So swap becomes an interesting idea because, let's say I'm talking about the value that's here, right? And I want to switch it with the other value in board index 1 minus 2. This is not going to work. This is not going to work. And the question is like, why wouldn't that work? So you have this location, and you say I want it to be equal to this location, and then you take the other location and say I want that to be equal to the other location. Why doesn't that work? Well, if this is holding a 2 and this is holding a 1, right? You're saying I want this location to now be 1, right? And now this location, which is still holding a 1, you want to say I want it to be the value of this location. Well, what's this location holding? This board index negative 1 minus 3 is now been updated to also hold 1. So the problem with this kind of thing is it doesn't create a swap. What it does is create two locations that have the same value. And so that's now showing. So the question is like, you need to hold on to this value because this value, the value in that location is going to be changed. So you need to hold on to that value somewhere to have it available when you want to assign the value to the other spot. So the way you do this, you create a temporary variable. So like you could say temp equals board index negative 1, negative 3, and then this guy here would equal temp. And so consider this idea. This is a very classic algorithm, by the way. Very classic algorithm. So think about that. That works. Now, what I showed you originally was sort of a shortcut that's available in Python. It's not available in all programming languages. So it's a good thing to understand how this algorithm works, right? So I create a variable. I hold on to the value. The value in a certain location. I then change the value in that location, right, with the value in another location. I then go to the second location and say I want that to be the original first location value, which has been changed, but has been held onto in a temporary variable. And so I can now find that original value and give it to the second location. So, okay. So anyways, that's all good. So what I'd like to do, so I'm not going to show you display board. So I'm giving you make board. So just, you can use this code, make board. It's going to create these boards. You got to come up with display board, which is a pretty fun, interesting challenge involving print statements. Make sure you remember the end equals kind of construction or whatever. But let's run something here and see how this code goes. Okay, great. So I have display board working, and display board works as expected, right? So now let's come down into this code, and this might freak you out. That's what I kind of talk about a little bit about. But you've got to sort of, to be able to solve this thing, you've got to be able to figure out these other functions you have to write and what these other functions are going to do. So tile equals int input tile. Okay, so users just give us a tile value. And then we have to find the blank tile. We have to find the tile. So I'm saying tile equals find tile, and I'm being given the tile value. And then I go down here and then I say, valid move, and I use blank index 0, blank index 1, tile index 0, tile index 1. So that's kind of revealing is like valid move and swap tile both refer to a first and second location for blank and a first and second location for tile. So for me, that kind of suggests a tile for our purposes is a list. I think what I actually originally did is I made them tuples, but the tuples are basically like lists. It just can't be mutated, so that's fine. Whatever. So we can use lists, and we're going to be good to go. Anywho's, so it could be a little confusing because of the variable name there. I will say maybe I should change the variable name. I could call this tile location, and maybe I'll do that for you guys too. All right. So as you write these other methods, so tile equals input, that's just a line, it's nothing. Blank, find blank, and I want blank to have two values, for it. So does it make sense that if I'm referring to the location of either a number on the board or the blank spot on the board, that that location will have two values, both a row and column value, right? For location, row and column value. So originally, this blank spot is in the I guess you could say it's in the -1 location. Yeah, I guess you could. But I'd probably just, for my sanity, want to refer to things in a positive sense. So I would say it's in the 3-3 location. That's what we want to do with this function. So let me see if I can do this without giving everything away. There we go. All right, so here's my actual working solution. And I'm going to think about writing this find blank function. By the way, does find blank take any parameters? No, it doesn't. Right? It doesn't take any parameters. So so it looks like this. That's going to start. And remember that when I return something and it gets stored in blank, the variable blank, that it needs to have two values, the row and column location, right? So what I need to do is I need to iterate through the board. So at this point, I don't really know what n is. So let's say n is equal to the length of the board. N is equal to the length of the board. Does that make sense? N is equal to the length of the board. It is that's however many lists are in the board, and so that's like the board. So I'm going to say for I in range n, for j in range n. And if I were to iterate through this thing, right, if I were to say something like board index I index n, right, that board not n, but j, that board index ij is going to go through every single spot in the board, right? Because it's going to go 0, and it's going to go 0, 1, 2, 3 for j. It's going to go 1 for I, then it's going to go 0, 1, 2, 3, however many rows we have, kind of thing. So anyways, that's going to iterate through the whole thing. What are we looking for? If we're looking for blank, right? If we're looking for blank, what's the value sitting in the blank spot? The value sitting in the blank spot is 0, right? So what I would say is if board index ij, right, equals 0, that means we found the blank location. And what I'd like to return at this point, is there a way to do this without? Yeah, I mean, I guess I could just make it a list, right? Let's make a list. Now, the only difference between a list and a tuple is a list has the square brackets and a tuple has parentheses. And they behave very similarly. Just tuples are not mutable, so you can put parentheses on there. And the funny thing is, in Python, if you don't put anything here like this, it just automatically makes it a tuple. So it makes it like as if there were parentheses. But whatever, we'll make it a list. It's not going to affect anything. Okay, so here is the deal. Here's the deal. I have a row and column location now for the blank tile. And let's see how this works. Oh, I haven't made this thing open up. Cancel. Do I want to? I probably don't want to comment out the while true right now. Probably don't even want to comment this out right now. But let's do this. Let's see how this goes. I'm gonna have to pull it over, but I can put it back later. Boom. Okay. So, question. Didn't look like anything new happened, even though I sort of made this area sort of live in the program. Blank equals find blank. So, but remember that find blank returned ij, right, as a value, and stored it in something called tile, right? So if I were to look at or I don't think stored in something called blank. So if I look at blank right now, I should be able to look at blank. Yeah, blank is a list which has 2 values in it, right? And then look at the other function there, how it's saying blank index 0. By the way, what does that refer to? You know, what does that refer to? When I look at the first, now it may not be obvious because they're both the same number, right? But what is that referring to? That first thing referring to? It's referring to the row. It's referring to the row that that the blank spot is in, and the second value is referring to the column that blank is in, and they both have the same value. Now remember this, that the space though is not always going to be in 3-3. It's always going to start in that lower right corner, but as we start to play the game, it's going to move around. Right, it's going to move around. Why is it important to know where the blank tile is? Well, you can only move tiles that are in these positions to the blank tile, right? You can only move tiles that are vertically above or horizontally right next to the blank tile. So you have to know where that tile is, and you have to then check to see if the tile that the person's entering is next to the blank tile. And if it's not, then they can't make that move, right? So we also have a function here which checks to see if it's valid. If it does, it makes a swap. Otherwise, it prints not a valid move. Redisplays the board, it checks for the win, and then just kind of keeps redoing the thing. So, so that's pretty good. I think there's a lot of thinking going on here. Really requires some paper pencil, and you really got to get into this 2-dimensional array kind of thing. You got to think about rows, columns, ij. But anyways, good challenge. So enjoy.